I am Dr. Suresh, Associate Professor in Mechanical Department, Rajalakshmi Institute of Technology. Now we are going to discuss about the finite element analysis. Peculiarly in the finite element analysis, we are going to deal about the one-dimensional problems. Okay, in the one-dimensional problems, it has been characterized into 4 to 5 steps. I am going to deal with all the steps in the detailed manner. See, actually, this is the stepped bar. Okay, in the one-dimensional problem, this is the basic structure of the stepped bar. In the stepped bar, the length of the stepped bar is just L. Just in this point, we are going to deal with the load. The stepped bar is subjected with the load at the end. In the first step, while solving the one-dimensional problem, the first step is that we have to discretize the entire structure into, according to our usage, we can discretize the entire the bar into finite elements. In this problem, I am going to discretize the entire the bar into 3 elements. Okay, this is the first element, this is the second element, and this is the third element. Okay, to represent the element, normally I am going to write the 1 with the end circle. Okay, it means that if it is being encircled, the encircled parameter is called as the element. Then this is the number 2, then this is the number 3. Okay, so that the entire element is going to be splitted. It means discretized into 3 elements. Each element will have the 2 nodal points. Okay, this is the nodal point 1, this is the nodal point 2, this is the nodal point 3, then this point might be the 4. Now I am going to write the number 1 over here, number 2 over here, number 3 over here, then the number 4 over here. Then automatically it has been provided, this element has been provided with 4 nodal points. Okay, see now I am going to take the first element. Okay, how to solve this entire problem in the detailed manner. I am going to solve the in the earlier session, just we are deal with the how the element has to be characterized, how the element has to be split into different discretization parameters. In the first element, okay, just I am going to take this one as our first element. This one as our first element. This encircled parameter is called as the first element. It has been provided with 2 nodes. Okay, it has been provided with 2 nodes. Okay, first we have to find out the stiffness matrix of the element 1. Now I am going to write the stiffness matrix over here. The formula to find out the stiffness matrix is A1 E1 divided by L1, then the matrix of 1 minus 1 minus 1 and minus 1. This is the formula through which we can easily find out the value of stiffness of this particular element. Okay, now this A1 represents the area of this entire element. Okay, then this E1 is nothing but Young's modulus, then L1 is nothing but the total length of this element. Okay, now this is K1. Now I am going to substitute the values of this all the elements. Now this area 1, now let us assume that the area 1 is A1, then E1 is nothing but E1, then L1 just I am going to represent as the L1. Now this is the matrix of the first element. Similar manner, I am going to find out the stiffness matrix of the second element. See, the encircled value is a notification of the element 2. Now this has been splitted. This has been noted as number 2 node. This has been noted as number 3 node. Now I am going to write the element matrix for the second element. This is actually called as A2, then E2 divided by L2, then the matrix of 1 minus 1 minus 1 minus 1. This is the value through which we can easily find out the stiffness matrix of the element 3. Similar manner, the element 3 value also must be find out. Okay. This is the third element. This third element has been provided with the 2 nodes, this third node and the fourth node. Now I am going to find out the value of the stiffness matrix of this third element. This is actually A3, then E3 divided by L3. Similarly, see, this is the matrix through which you can easily find out the value of the element 3. Now, after finding out of all the stiffness matrix of the all elements, now I am going to assemble all the parameters into in order to find out the global stiffness matrix. How to find out the global stiffness matrix? See, it has to be the notification to represent the global stiffness matrix is the kg. Okay, now this is the value of the all the elements, the cumulation of all the areas. The rank of the matrix would come around as okay. Here, see the first during the this value. Okay, see this value has to be added with this value. Both the values has to be added together in order to find out the value of the stiffness matrix in that global stiffness matrix. Okay, now when we add this value, it becomes as number 2. Similarly, this is actually this is the parameter, then this is -1 will come, then this is -1, then this is -1. Then similarly, this has to be added with another one. See, this is the value of this value. This has to be added over here. Then this -1, this -1, this -1. Then the remaining values has to be set as 0. Now, the rank of the matrix is 4 cross 4. This is the value of the global stiffness matrix of this particular problem. See, after finding out of this global stiffness matrix, we have to find out the values of the extension, which we have to find out the extension of this stepped bar. See, how to find out the values of this stepped bar? Now, the formula is that the F vector equal to K into U. Okay, see, the force equal to stiffness matrix in the displacement. Through this formula, we can easily find out the value of this U parameters. How to find out the values of U parameters? See, here actually it has been substituted with 4 types of forces over here, because it has been this particular element I have been categorized with 4 nodes. So that is 4 elements. That's why I am assuming that each element has been subjected with force 1, force 2, force 3 and force 4. Similarly, this K1 AE EE divided by LE, then this value has to be written over here. 1, -1, 0, 0, -1, 2, -1, 0, 0, -1, 2, -1, 0, 0, -1, -1. Then this elongation. Then we have to substitute the boundary conditions of this particular problem. How to substitute the boundary condition? See, based upon the problem, in this entire problem, in the fourth node, that means third element, fourth node, I am going to apply the force. So that boundary condition, while applying the boundary condition, in the element 1, in the first node, I am not going to apply any forces over there. That's why it has been fixed as 0. Similarly, F2 also I am not going to apply any force. That's why it is marked as 0. Similarly, F3 also I am not going to apply any forces. That is why it is marked as 0. But whereas in the F4, I am going to apply the force. That's why it has been represented as P. Okay. Similarly, U1. Okay, because the element 1 has been completely fixed. Okay, that is why I am not going to get any elongation over there. That is why it has been marked as 0. Similarly, U2. Okay, since it is the element 1 part, the node 1 is being completely fixed, we can't find any the elongation over there. That is why it has been marked as 0. But whereas in the node 2, we can find some elongation. That's why it has been marked as question mark. Then similarly, Y3 equal to, there might be some elongation. Similarly, Y4 equal to, there might be some elongation. So, all this boundary condition has to be substituted in this formula. Now, here, while finding out that global stiffness matrix, here I have marked as +1. But here it is mentioned as -1, so it has been corrected. It has been corrected as +1. Now, in that entire element, in the step 1, in the element 1, we are not going to apply any load. That's why it is marked as 0. The F2 similarly, F2 also we are not going to provide any load. That's why it is marked as 0. But whereas F4 we are going to apply the load. That's why it is represented as P. Okay. Now similarly, U1 it has been completely arrested. That's why we are not going to get any elongation over there. But whereas in the U2 we are expecting some elongation. Similarly, U3 also we are getting some elongation. Similarly, U4 also we are going to get some elongation. Now, all this boundary condition has to be substituted in that main formula. Now, I am going to substitute that values in this main formula. Now, F1, as I said earlier, the F1 should be marked as 0. Similarly, F2 also should be marked as 0. F3 also should be marked as 0. But whereas in the place of F4, now I am going to write the load P. Okay. Similarly, this global stiffness matrix has to be written over here. Now, this AE, this EE, then this LE. Similarly, this parameters, whatever the value which has been found over here, this has to be written over here. This is -1. Similarly, this is -1. Then this values has to be substituted over here. This in this particular cell, I am going to get the value +1. But whereas here -1, then this is 0. Then this part
மேலே வைங்க.